Hello viewers, today we'll be talking on formation of partial differential equation by elimination of arbitrary functions. Here I have on the board that suppose z is a function of two arbitrary functions. We have to find partial derivative up to second order and use the partial derivation of the second order to form the P.D.E by eliminating the arbitrary function. It means whenever we are given a relation or equation forming of a P.D.E by eliminating the arbitrary function, it means we are differentiating partially variable that we are given there by the function. So it means we are going to differentiate twice, whereby we are going to differentiate if it is x and y partially with respect to x, then we are going to differentiate partially with respect to y, then we form a what P.D.E where we get our what from the second order. Then if it is more than, if from the second order we are not able to get our what new partial differential equation for the function, it means we are taking it up to what higher degree. So I have example one here. We have to form a P.D.E by eliminating the arbitrary functions in the following function. Z is what? F of what? X squared plus y squared. It means for us to solve this one, we are going to differentiate partially with respect to x in equation 1. I will name this one as equation 1. Then differentiate second times again, partially with respect to what? With respect to y in equation 1 as well. So from equation, from differentiating partially with for my y, when I differentiate partially with respect to y, then from there I'm going to get my what my new equation, which is going to what replace the what arbitrary function. Then from there I'm going to eliminate the arbitrary function. So let us start. Z is f of x squared plus y squared. I can name this given relation as equation 1. So what I'm going to do is I'm going to differentiating partially with respect to x in equation 1. So I'm going to differentiate partially with respect to s in equation 1. I have z there. If I differentiate z with respect to s, I'm going to have partial z over partial x, or the z over the s is equal to. So I'm going to differentiate this function f of x squared plus y squared having a function with respect to what? With respect to x. What am I going to do here? I can apply chain rule in this given equation. If I have f is equal to what? X squared plus y squared. So let's say this one is y. So it means for me to solve this one by chain rule, I'm going to differentiate the first in brackets by letting another variable to replace it, to represent it. Let's use equal to what? X squared plus y squared. If I differentiate u here with respect to u, I'm going to have d over ds as what? I'm only differentiating with respect to what? X. You have 2x. So this one will be plus 0 because I'm differentiating with respect to what? With respect to x. So what is my next step? My next step is to what? To let y is equal to f. What is my x squared plus y squared is what? U. Let me differentiate this one with respect to what? U. With respect to f, I'm going to have f prime of u. This f is a function of this u. I don't know what this f is. So that's why I have f prime of u. Whenever I differentiate f, I'm going to have what? F prime of u. I'm not going to multiply our du over ds times what? Dy over df. So I'm going to have 2x f prime of u. So because 2x, so what's our u? Our u is what? X squared plus y squared. X squared plus y squared. So it means when I differentiate this, I have what? 2x f prime of what? X squared plus y squared. So it means that if I'm differentiating with respect to what? Y, where I have 2x here, I'm going to have what? 2y. I'm only considering y squared, not x squared. Here is what? Plus 0 because I'm differentiating with respect to what? With respect to x. So what's my next step? Remember that the z over the s, the notation for the z over the s is what? P. So I'm going to have P is equal to 2s f prime x squared plus y squared. So my next step is what? To differentiate equation 1 again, partially with respect to what? Respect to y. Differentiating partially with respect to y in equation 1. So if I have z, I want to differentiate with respect to y, I'm going to have di z all over di y, or partial z over partial y is equal to, I want to differentiate f of x square plus y square with respect to y. So it means I'm going to have what? I'm only differentiating y square, which is what? 2y. If I differentiate y square here, I'm going to have 2y. If I differentiate x square here, it's going to be 0 because x is not a function of y, so I'm going to have 0. So I will differentiate inside with respect to the value, which is where 2y. Differentiate f, I'm going to have f prime. Then multiply by what? The function of x square plus y square. So it means if I differentiate equation 1 partially with respect to y, I'm going to have 2y f prime x square plus y square. So I'm going to have 2y. Remember that our z all over the y is what? Q. So I'm going to have q is equal to 2y f prime x square plus y square. So what is my next step is what? Since I've differentiated with respect to x and y, so I'm going to consider it by eliminating. How can I eliminate the arbitrary function from here? F prime and f prime from this given equation 2. I can label this one as equation 2, then label this one as equation 3. So how am I going to what? Eliminate the arbitrary function from this given equation 2 and 3. So for me to do that, I'm going to consider that differentiating equation what? Equation 2 by equation 3. Then if we differentiate, we compare together, then we remove the what? Arbitrary function. So divide equation 2, divide equation 2 by equation 3. So I'm going to have P is equal to 2s f prime x square plus y square divided by what? Q, which is what? 2y f prime x square plus y square. So what am I going to have next? So if I differentiate y f prime x square y square is common here, I can cancel them out. 2 is here, 2 is here. So I'll be left with what? P over Q is equal to what? X over y. I'm going to cross multiply. If I cross multiply, I'm going to have Py is equal to what? Sq. So I can take this Sq to what? Left hand side. So I'm left with what? Py minus what? Sq is equal to 0. Which is the required P.D.E? Which is the required P.D.E? It means I have what? I have formed a new P.D.E by eliminating the what? I eliminated the arbitrary function, which is what? Py, which I get Py minus what? Sq is equal to 0. It means this is the solution to my given problem. It means I've eliminated what? I've eliminated the what? Arbitrary function by what? By getting a new partial differential equation, a new what? P.D.E, which is what? Py minus Sq is equal to 0, which is the solution to the given problem. I hope you find it interesting. Thanks for watching.